Hey everyone, this is Bhargav Sudhar, and in today's session we will discuss types of function. In previous session we discussed what is a function and some 2 or 3 types. Now in this session we will discuss some rest of the types of a function. Now let's understand what is a one-one function or an injective mapping. So a function f from a to b, it is said to be a one-to-one mapping or one-one mapping or one-to-one correspondence or injective function. If for every a1 a2 belongs to a, f of a1 equals to f of a2, that implies a1 equals to a2. And now what does that mean? So if we take two elements a1 a2 belongs to some set, now if their image is same, okay, then that element has to be same, or in different manner, if a1 not equals to a2, that implies f of a1 not equals to f of a2. So that means if we have two different elements, then their images also will be different. For example, a function f, it is from a to b. Okay, now let us take a equals to 1 2 3 4 and b equals to x y z t and q. Now let us graphically understand this. So that is, just name it as a, then take a second set b, name it as b. Okay, fine. Now a has how many elements? That is 1 2 3 4, and b has x y z t q. Now one's image is x, two's image is y, three's image is z, and four's image is t. Now you can see that all the elements have the images. Obviously it has to be a function first, so it is a function, but all the different elements are there, so their images also are different. Okay, fine. So this is the one-to-one function. Now let us understand what is an onto function or a surjective function. So a function f from a to b is said to be an onto mapping if each element of b is the f image of at least one element of the set A. Okay, so in this case, the range of f, it is the codomain of B, that is f of A equals to B. Fine. Now again take an example. So let a function f from A to B, then this A equals to 1 2 3 4 and B equals to x y z. Fine. Now let us understand by graphical. Now take A, okay, then take second set and name it as B. Now the elements are 1 2 3 4 in A, and the elements in B are x y z. Now see, one's image is x, two's image is y, three's image is also y, and four's image is z. Now what is the definition? That means each element of B, so that means each element of B, that is x y z, is the f image of at least one of the set A. So that means in short, this all the elements of B has to be occupied. Okay, that means all the chairs has to be occupied by some student. Fine. So it is very easy. Now let us understand what is a one-one onto function, or that is bijective. So a function f from a to b, which is one-one as well as onto, is called a bijective function. For example, take a function f from a to b, that is a equals to 1 2 3 and b equals to x y z. So what will the graph? Take a, let us name it as a, and take second circle, name it as b. Now the elements of a are 1 2 3 and the elements of b are x y z. Now it is one-one as well as onto, so that means all are different and their image is also unique, and all the elements of b has to be occupied. Fine. So one's image is x, two's image is y, and three's image is z. So this is the one-one and onto function. Now let us understand what is an inverse function. So if f equals to a to b, f is from a to b, is an one-one onto function. So first it has to be a bijective mapping. Okay, then the mapping f inverse, it is from b to a, which associates to element b belongs to b to the unique element a belongs to a, such that f of a equals to b, and is called the inverse mapping or inverse of the mapping f from a to b. Now note, now see, if f is bijective, then only this f inverse exists, and that inverse will also be a bijective mapping. Now let us understand this. Just take one set A, okay, then take second set B. Fine. Now if f is a function from a to b, fine, then its inverse will be from b to a, and that is f inverse. Now let us understand an important topic, that is composition of functions. Now let a, b, c be three sets. Fine. And let f is from a to b, and we have another function, that is g, from b to c. Okay, so these two are functions. Now then, this GOF, it is the composition of f and g, and that will be from a to c. That is GOF of a. That is GOF of a. Fine. Now g of f of a, that is same as g of f of a. Now what is f of a? Let us take f of a equals to b, so that is g of b. So, and that let us take a g of b equals to c, that is for every a belongs to a. Now let us understand by graphically. We need to have three sets. Fine. So let us take a and then b. Now see, uh, some element that is a. Now its image is in b, and let us take b. Okay, fine. Now that is the function f. It is from a to b. Now then take third set, that is c. Then b to c. The function g, it is from b to c. Fine. So f is from a to b and g is from b to c. Then this GOF, that is GOF of x, it will be from this a to c. Now let us take example. Let f of x equals to x plus 2, g of x equals to x minus 2, and h of x, we have third function, that is q of x, for every x belongs to R. Okay, so find this GOF, FOF, HOG, FO, HOG. So that means we need to find all the compositions. So the first step, see, GOF of x. So what does that mean? It is g of f of x. Now just substitute the value of f of x. Now what is f of x? That is x plus 2. So g of x plus 2. Now what is g of x? G of x is x minus 2. So that means here whatever the x is there, just subtract 2. So if we have x, that means subtract x minus 2. If we have something, then something minus 2. So here that something is x plus 2. So the answer will be something minus 2. So that means x plus 2 minus 2. So the final answer will be x. Okay. Now what is f of f? So that means f of x. Fine. Now just substitute the values of f of x, that is x plus 2. So f of x plus 2. Now what is f of x? F of x is x plus 2. And here we have f of x plus 2. So f of x is x plus 2. That is something plus 2. So here this something is x plus 2. So x plus 2 plus 2. So that means x plus 4. So this is how you can calculate composition. Let us take HOG of x. Now what is HOG of x? That is h of g of x. Now substitute the value of g of x. So g of x is x minus 2. Now what is h of x? H of x is 3x. But here instead of x we have x minus 2. So 3x, 3 times x minus 2. And that is 3x minus 6. Fine. Now last one, FOHOG of x. So step by step we will do it. So this can be written as f of h of g of x. Now substitute the value of g of x, that is x minus 2. Now just go for h. Okay, so h of x minus 2 will be 3 times x minus 2. Why? Because h is 3x. And last, f of something, so that is f of 3x minus 6. Now what is f of x? F of x is x plus 2. So that means instead of x we have this whole bracket. So this bracket plus 2. And the final answer will be 3x minus 4. Let us take second example. Now here we have function f of x equals to 4x plus 3 divided by 5x minus 2. Then find f inverse. Okay. So we will have to find the inverse. Now set y equals to f of x. So first step, just take y equals to f of x. So therefore this y equals to 4x plus 3 divided by 5x minus 2. Now just interchange the values of x and y. Okay, so if we interchange, what we'll get, just instead of y write x. So x equals to 4y plus 3 upon 5y minus 2. So just cross multiply. So 5xy minus 2x equals to 4y plus 3. So therefore just after opening the brackets and just combine the values of x and y. Fine. So you will get y 5x minus 4 equals to 2x plus 3. So that means y equals to f inverse of x, and that is 2x plus 3 divided by 5x minus 4. Thank you.